Okay, 8th grade, this is the Chapter 7 Study Guide number 1 video. You should have your math binder with you, and Study Guide number 1 covers pages 1 and 2 in your math binder. I'll read the problem from your page and work it out on this board. As I work it out, this is similar work that you should show on your paper to solve the problem. Number 1, we have this table here of the two shuttle surfaces, and the question says, choose the equation you could solve to determine the number of miles in which the cost of both shuttles is the same. Okay, so we have the classic shuttle, which charges $10 for pickup plus 20 cents per mile. If you see the word per, P-E-R, that's going to signal multiplication. And so if we write an expression to represent how much we'll pay for the classic shuttle, we would pay $10 just to have them pick us up. So we're paying $10 plus 20 cents, or 0.20, 20 cents per mile, or 20 cents times the number of miles. And so I'm going to use a variable to represent the number of miles because I don't know the number of miles. That's my unknown. And that's simply what a variable is, right? A number to represent, or a letter to represent an unknown number. So I'm paying $10 plus 20 cents times the number of miles. Let's just use X for our variable, X, the number of miles. So the classic shuttle, I'm going to pay 10 plus 20 cents per mile. Now what about the easy transfer shuttle surface? It says no pickup charge, so I'm going to pay nothing, right? No dollars to have them pick me up, but I will pay 45 cents per mile. So no pickup charge, so I don't really even need the zero. I'm just going to pay 45 cents per mile, so 0.45 times the number of miles. And again, I'm using X to represent the number of miles. And remember, we're asked to find an equation in which we could solve to determine the number of miles, in which the cost of both shuttles is the same. And so we want to know, when will classic shuttle be equal to or the same as the easy transfer? And so what we could do is set this expression equal to this expression so that we would know at what mileage the two would be the same. So 10 plus 20 cents per mile, or 0.20x, is equal to or is the same as the easy transfer shuttle, 0.45x. Okay, so we could use this equation and we could solve for x, and x would tell us the number of miles in which both shuttle costs would be the same. That's number 1. This is letter C. Letter C is the answer for number 1. Okay, number 2. Number 2 says a painter charges a flat fee of $100 plus $22 an hour. A second painter charges a flat fee of $70 plus $25 an hour. After how many hours is the charge for the two painters the same? So we want to know, first off, the first painter, what does he charge? Well, he charges a flat fee. If you see the word flat fee, that's a one-time charge. So if you hire the painter, you're paying $100 up front. So let's say first painter, right? The first painter charges a flat fee of $100. So I'm paying $100 right up front. Plus I also pay $22 an hour. An hour, that expression is similar to per hour. Okay, and anytime you see the word per, P-E-R, you know you're multiplying. In this case, $22 times the number of hours. So I'm paying $100 up front plus 22 times the number of hours. Again, let's use X, the variable X, in this case, to represent the number of hours. X will represent the number of hours. So the first painter charges $100 plus 22 times the number of hours. That's the first painter. The problem also says a second painter charges a flat fee of $70. $70. So the second painter, if you hire this painter, he's charging $70 flat fee. So you're paying $70 up front plus $25 an hour. So 70 plus $25 times the number of hours. And again, we're using X for the number of hours. Okay, and the question is, after how many hours is the charge for the two painters the same? And that's the key word, same. We want to know when will this first painter be the same as or be equal to the second painter? Okay, and so this is our equation to set it up. Now we need to solve for x, and again, x will tell us the number of hours. It will tell us when the left side is equal to the right side. Okay, so I see no parentheses. I do not have like terms, so I need to get my variable on one side. Let's get it on the right side so that the x term will be positive. So I'm going to subtract 22x from both sides, so those 22x's cancel. So I'm left with 100 is equal to 70, and 25x minus 22x is positive 3x. Since my variable's on the right side, get this number on the other side by subtracting 70, so that those 70's cancel. 100 minus 70 is 30. That's equal to 3x. Solve for x by dividing by 3, since that is the coefficient or the number in front of the letter. Those three simplify to 1 times x, which is just x, and so x is equal to 30 over 3, which is 10. And again, what is x? What does x tell us? X tells us the number of hours. And so after 10 hours, the cost of the two painters will be the same. So now we've answered our question. After 10 hours, the two painters will be the same charge. Question number 3. It says one side of an equilateral triangle is 9x minus 14. Another side of an equilateral triangle is 5x plus 38. What is the length of one of the sides of the triangle? Okay, so we're dealing with an equilateral triangle, right? And so for this problem, I would first draw an equilateral triangle so that I can visualize what is happening in the problem. So this is number 3. I have an equilateral triangle. Of course, I know a triangle has 3 sides, and because it is equilateral, this side is equal to this side is equal to this side, right? All the sides are equal to one another. Okay, so it says one side is 9x minus 14. That's the length of one of the sides. Another side is 5x plus 38. Okay, so I'm just going to call one side 9x minus 14, call the other side 5x plus 38. Again, it doesn't matter which side you call which because they're all the same thing, right? It's an equilateral triangle. So we need to find the length of one of the sides. So to do that, we need to know what x is so that we can plug x into one of those expressions. So how are we going to solve for x? Think about that. How are we going to solve for x? Well, I know that if this side is equal to this side, because it's an equilateral triangle, I can set this side equal to this side and solve the equation for x. So let's do that. Let's say that this side, 5x plus 38, is equal to or is the same as this side, 9x minus 14. Now I simply just solve the equation for x, right? I see no parentheses, so I don't have to distribute. I see no like terms. Now I need to get the variable on one side. Let's get it on the right side so that it remains positive. So I do that by subtracting 5x. So on the left side, I'm left with 38. I bring that straight down, bring the equal sign straight down. 9x minus 5x is 4x. You still have minus 14. Variables on the right side get this number on the other side. I have to undo the subtraction by addition, so I add 14 to both sides so that those cancel. 38 plus 14 is 52, and that is equal to 4x. Solve for x by dividing by 4. Okay, so x is equal to 15 divided by 4, which is 13. Now this is not my answer. It did not ask me to solve for x. It asked me what is the length of one of the sides. The sides are 5x plus 38 and 9x minus 14. But now I'm able to get that length of the side because I know what x is. I know x is 13. And so what I can do to find the length of one of those sides is take this value for x and plug it in either there into the expression 5x plus 38, or I could plug it in to this expression, 9x minus 14. It does not matter which one I pick because, again, this is an equilateral triangle. This side is equal to this side. So no matter which expression I plug it into, I'm going to get the same length for the side because they're all equal to one another. So just to show you that, to prove that that is true, let me plug it into both expressions and they should both equal the same number. So first let's plug it into 5x plus 38. So I have the expression 5x plus 38. Of course 5x means 5 times x, right? So I'm going to plug 13 in right there. So 5 times 13 plus 38, okay? got to multiply before I can add. 5 times 13 is 65, and then when you add 38, you get 103. So the length of one of the sides is 103. Now let's just make sure that we've done this right, that we've actually solved for the variable correctly. And so let's plug it into the other expression also. The length of the other side of the triangle was 9x minus 14. So again, plug x in here. 9x means 9 times x, so 9 times 13 minus 14. Okay? If you solve for this, you will also find that that is 103. Okay? So again, it does not matter which expression you pick to plug x into, you will get the length of the sides of this equilateral triangle are 103, and because there is no unit given, we're just going to say 103 units. That is the length of one of the sides. 103 units is your answer for number 3. Question number 4 says, which of the following equations has no solution? Okay, so we know when solving an equation, there are 3 possible results, right? You can either get one solution, you can get no solutions, or you could get infinitely many solutions. And so in this problem, we want to know which of those equations has no solution. Okay, so there's a couple different strategies. You could pick which one you think might have no solution and solve it, see if it has no solutions, or you could just go in order. Solve equation A, then solve equation B, solve equation C, and then D, and see which one has no solution. Okay, so let me start with equation A. Let's check and see how many solutions it has. Okay, the equation is 7g plus 14 minus 3g is equal to 6. Okay, I have no parentheses, but I do have like terms, right? 7g minus 3g, that's 4g. Still have plus 14 is equal to 6. Okay, I'm going to get 14 on the other side because my variable is on the left side. I'm getting the number on the right side. And so 4g is equal to 6 minus 14 is negative 8. I solve for g by dividing by 4. And so g is equal to negative 2. So that equation has one solution. Right, so that one's out because I'm looking for the equation that has no solution. So let me move on to equation B. Let's see how many solutions equation B has. Equation B, 4 times 3 plus x is equal to 8 plus 4x. Okay, I see parentheses. I'm going to eliminate the parentheses by the distributive property. 4 times 3, or 4 rainbow 3, that's 12, right? 4 times x is positive 4x. On the right side, I have no parentheses, so I'm going to leave that side as is. Now, I have no like terms, so I'm going to get the variable on one side. To do that, let's subtract 4x. Subtract 4x from both sides. When I do that, do you see what happens? These 4x's cancel and these 4x's cancel, right? Because 4x minus 4x is 0. So what I'm left with on the left side is 12 is equal to, on the right side, 8. Is this ever true? Does 12 ever equal 8? Are 12 and 8 the same thing? No, they are not, right? This does not make sense, and so therefore there would be no solution. Okay, there's no solution to this equation, and that's what I'm looking for in problem number 4. Which of the equations has no solution? And so this will be equation B. Equation B is your answer for number 4. Okay, problem number 5. I simply need to solve that equation, solve the equation for the variable r. Okay, so my equation in number 5, I have negative 2 times r plus 2 plus 5r is equal to 6r plus 11. Okay? I'm going to follow the 5 steps to solve equations. I can remember the 5 steps to solve equations by the phrase, every cowboy gets nervous sometimes. The E on every reminds us to eliminate the parentheses by the distributive property. And so here I see a negative 2 right next to parentheses, and so I need to distribute that negative 2. So negative 2 times r, that's negative 2r. Negative 2 times positive 2. Negative 2 times positive 2 is negative 4. Okay, and I still have this positive 5r that I will not distribute to because it is outside the parentheses. I bring my equal sign straight down, and on the right side I have no parentheses to eliminate, and so I bring the right side down. I just copy it straight down. Okay, so now my equation, I have no parentheses. I have eliminated them by the distributive property. Step 2, combine like terms. I look left. I see that I have negative 2r and positive 5r. They are like terms because they have the same variable r and the same exponent 1. And I know negative 2 plus 5, that is positive 3 or 3r. I still have a minus 4 bring the equal sign down. The right side I have no like terms, so I simply bring that expression down. Okay, now I move on to step 3, which is get. Get the variable on one side of the equation. Let's get it on the right side so that it remains positive. To do that, I'm going to subtract 3r. Those 3r's will cancel, and I'm left with negative 4 on the left side. Bring the equal sign down. 6r minus 3r is 3r, and I still need to add 11. Okay, now because my variable is on the right side, step 4, get the numbers on the other side. So I do that by subtracting 11, right, to undo that addition. 11 minus 11 cancels. Here I have two negative numbers, so be careful, right? We're adding negatives. So same signs add, keep the sign. Negative 4 minus 11 is negative 15 equals 3r on the right side. Solve for r by dividing by the number in front of the letter, right? Number in front of the variable, which is called the coefficient. In this case, that is the number 3. So I'm going to divide the right side by 3 and the left side by 3. Those 3's would simplify to 1 times r, which is r. And so r is equal to these numbers right here that have different signs that are being divided. Now, I will not say different signs subtract, right, because I'm not subtracting. I am dividing. I would say same signs positive, different signs negative, right? So I'm going to have a negative answer here. And I know 15 divided by 3 is 5. So r is negative 5. That is your answer for number 5. All right, so that is page 1. Let's go to page 2 now. All right, this starts with number 6. Number 6 says this: Seth weighs 190 pounds and plans to lose 2 pounds a week. Adam weighs 175 pounds and plans to lose 1 pound a week. When will Seth and Adam weigh the same? Okay, so we want to know when will they weigh the same. So we want to know when will Seth's weight be equal to or the same as Adam's weight. So first let's write Seth, all right? This is number 6. Seth, right, he weighs 190, so that's his starting weight. He's at 190, right? And he plans to lose. So his weight is going to be going down. So I'm going to need to take away from his weight. That's why I'm putting a subtraction sign, right? He plans to lose 2 pounds a week, or 2 pounds per week. So he's at 190. He plans to lose 2 pounds times the number of weeks. And so I'm going to make x equal to the number of weeks. That's my variable. That is my unknown. So Seth starts at 190 and he loses or goes down 2 times the number of weeks because he's going to lose 2 pounds per week. Okay, so that's Seth. And we want to know when will Seth's weight be equal to or be the same as Adam's weight. So let's put Adam on the right side. And the problem tells us that Adam weighs 175 pounds. So that's his starting weight, right? He starts at 175 and he plans to lose. So if he's losing weight, he's going down. That's why I'm putting a subtraction sign. He plans to lose 1 pound a week, or 1 pound times the number of weeks. So 1x. So to figure out when will they weigh the same, I need to solve this equation for x. And x will be the number of weeks that it takes for them to weigh the same. So let's get I have no parentheses to eliminate, I have no like terms to combine, so let's get the variable on one side. Let's get the x's on the right side so that they are positive. To undo the subtraction, I would add 2x to both sides, so those 2x's cancel. So 190 is equal to 175, and here I have negative 1x plus 2x. Well, they have different signs, so I would subtract and keep the big guy. And so I would get positive, right, because the positive number is the big guy, and 2 minus 1 is 1, right? 1x. Don't forget your variable. So negative 1 plus 2 is 1x. Because my x, or my variable, is on the right side, I should get this number on the left side by subtracting 175 so that those 175s cancel. 190 minus 175 is 15, and that is equal to 1x, or just x. And so we solved the equation, right? X is 15. And what does x tell us? X tells us the number of weeks. And that is what the question asks us to do, right? When will Seth and Adam weigh the same? They will weigh the same in 15 weeks. They will weigh the same in 15 weeks. If you were to take 15, the number 15, and plug it in right there and plug it in right there, the left side would equal the right side, right? They would be the same weight after 15 weeks. Problem number 7 says this. It says, 2/11 times a number plus 16 is equal to 4 more than 6/11 times the same number. What is the number? Okay, so for number 7, I have here 2/11 times a number. So number 7, this is 2/11, the fraction 2/11 times a number. So a number, let's call the number x, right? 2/11 times some number. And I'm using my unknown, my variable, x here. So 2/11 x plus 16. That's what the problem says, right? 2/11 times the number x plus 16 is equal to, so I put my equal sign. And on the right side, I'm going to have 4 more than 6/11 times the same number. So I have 6/11 times this same number, 6/11 times that same number x. And remember, I want 4 more than this. And if I want 4 more than that, I would simply add 4. So there's my equation, right? I have to be able to read the language, set up an equation. Once I have my equation set up, I see that I have fractions in that equation. I want to get rid of the fraction. And to get rid of the fractions, I need to multiply both sides of the equation by the LCD, the least common denominator. I see that I have denominators of 11. Okay, so to multiply both sides by 11 would be a way to eliminate those fractions. So put the left side in parentheses and multiply by 11, or 11 over 1, and multiply the right side by the same thing, by 11, or 11 over 1. Now, because I have parentheses, I need to eliminate the parentheses by the distributive property. So 11 times 2/11x. See how I use my rainbow? 11 over 1 times 2/11x. Then I have 11 times 16. 11 times 11 over 1 times 16. Bring the equal sign straight down. I distribute here too. 11, or 11 over 1 times 6/11x. And then I have 11 times 4. 11 over 1 times 4. So do you see how I'm multiplying both sides of the equation by the same number, 11? I'm multiplying the left side by 11 and the right side by 11. Every single term in the equation gets multiplied by the same number so that the equation stays balanced. Now let's go through and let's cross simplify. Here I have 11 over 11. I know 11 over 11 is the same thing as 1 over 1. So I have 1 times 2x, and 1 times 2x is simply 2x. Here I have 11 times 16. 11 times 16 is positive 176. Bring the equal sign straight down. Here I have 11 over 11, which can cross simplify to 1 over 1. So I have 1 times 6x, which is just 6x. And here I have 11 times 4, which is positive 44. So now, because I multiplied both sides by the LCD of 11, I have no fractions in my equation. Right? This equation is much nicer. I can solve from here. Let's get the variable on one side. So I subtract 2x from both sides to get the variable on the right side. 6x minus 2x is 4x. I still have plus 44. Variables on the right side get this number on the other side by subtracting 44, right? So those 44s cancel. 176 minus 44 is 132. That's equal to 4x. Solve for x by dividing by 4. And so x is equal to 132 divided by 4, which you find is 33. And so the question is, what is that number that they were talking about? That number is the number 33, which means if you take that number 33 and you plug it back in for x into the original equation, you will get the left side equal to the right side. And so that number is 33 for number 7. Okay, number 8. Let's read the problem. It says the Pep Club. The Pep Club sets up a hot dog stand for fundraising in which they plan to sell each hot dog for $1.50. They received $22 in donations while setting up. To buy supplies, hot dogs cost 70 cents each and $47 in paper plates and napkins. Which equation would show how many hot dogs they sell to break even? Okay, if they break even, that means they make zero profit. So basically the money that they put into it is the same amount of money that they get out of it. Okay, so for number 8, the money that they put into it, or the money that they spend, is equal to the money that they make out of it, right? The money that comes in, or the money that goes out, excuse me. Okay, this would mean that they break even. And so here they sell each hot dog for $1.50. So money coming in, right? This is money that they make? They get $1.50 times the number of hot dogs, right? They're making $1.50 times every hot dog. And let's call hot dogs X, right? X is the hot dogs. So they make $1.50 times the number of hot dogs, right? They also received $22 in donations. So not only are they bringing in money from the hot dogs, they also got a $22 donation. So this describes all the money that they made, the money coming in, right? This is hot dog money. This is donation money. Okay, now I'm going to set this equal to the money that they had to spend. And it tells me that to buy the hot dogs, they cost 70 cents each. So the hot dogs were 70 cents each, or times the number of hot dogs, right? Plus, they had to spend $47 in paper plates and napkins. So not only did they have to spend 70 cents for each hot dog, but also $47 for paper plates and napkins. Okay, so now, because I have money coming in equal to money going out, or the money that they had to spend, this means they will break even. Break even, right? Whatever they make is equal to what they spent. That means they broke even. So now I'm looking for the equation, the options, where I have this equation. 150x plus 22 is equal to 70 cents x plus 47, and that would be option B. Option B is that equation. Okay, number 9. How many solutions does the equation have? And number 9, how many solutions does the equation have? Okay, so let's write that equation down. Number 9 says 3 times x minus 1/3 is equal to 6 plus 3x. Okay, I see parentheses. Let's eliminate the parentheses by the distributive property. So 3 times x is 3x. Then I have 3 times negative 1/3. So positive 3 times negative 1/3. I'll go back here in a minute and simplify that. The right side stays the same, right? It has no parentheses. Okay, so I have 3x. Can I simplify 3 over 1, 3 over 3? 3 over 3 is 1 over 1, right? So I have 1 times negative 1. 1 times negative 1 is negative 1. The right side stays the same. Let's get the x on one side, get the variable one side by subtracting 3x. When I do that, those 3x's cancel and those 3x's cancel, right? So on the left side I have negative 1, and on the right side I have 6. Is this ever true? Does negative 1 ever equal 6? No, it does not, right? And so I get something that does not make sense. And if I get something that does not make sense, there's how many solutions? No solution, right? There is no solution to the equation. There is no value for the variable that works to satisfy the equation. Okay, number 10, last one. Says, what value of k will create an equation with infinitely many solutions? Infinitely many solutions. Now remember, to have infinitely many solutions, you need some number equal to that same exact number, or the same expression equal to the same expression. Okay, so in number 10, the equation is 4 times 3x plus 12 is equal to 12x plus k. And we want to know which value for k is going to make this equation have infinitely many solutions. Okay, I see parentheses. Let's get rid of the parentheses by the distributive property. 4 times 3x is 12x, and 4 times 12 is positive 48. Okay, that's equal to 12x plus k. Now look at the left side. The left side I have 12x plus 48. 12x plus 48. On the right side I have 12x. So this is the same as this, right? And so basically I need to get this second term to look the same. This term is 48. This term is 48, positive 48. So I need to know what value for this term should I have so that this looks the same. Well, I should have 48, right? That way the left side would be 12x plus 48, and the right side would be 12x plus 48. Okay? When this occurs, when the left side is equal to the right side, or the left side has the same stuff as the right side, there is infinitely many solutions. And so the value for k that you should have is 48. That would make this equation have infinitely many solutions.